In today's lesson, we're going to talk about ellipses and understand the difference between circles and ellipses. But first, we're going to begin by classifying and reviewing the ideas of classification of our different conics. Remember, when you are focusing on this, you're focusing on the squared terms and then also the numbers that come in front of those square terms. So in this first term, we have two squared terms. They're both positive, but the numbers, the coefficients in front are different. So this is going to be an ellipse. Our second equation, once again, they are both squared terms. They are both positive, but the coefficients are the same. So this is going to be a circle. Our third problem, they are both squared terms again. They are both positive, but our coefficients are different. So this once again is going to be an ellipse. Our fourth function, we have one squared term and only one squared term. So this is going to be a parabola. Our fifth problem, we have two squared terms. One is positive, one is negative. It doesn't matter about the coefficients because one is positive and one is negative. That means this is a hyperbola. Our sixth problem, we have no squared terms. We have a 3x and a 2y, so this very simply is a line. Our last problem, we have both squareds, but one is positive and one is negative, and as a result, this is going to be a hyperbola. This is the fourth time now that we've worked on classifying. It's really going to be important as we look towards our test to make sure that we understand how to classify appropriately different conic sections when given in our standard form like that. Now, we're going to focus today specifically on ellipses, and I want to write down our standard form of what the equation of ellipse is going to be. Very similar to a circle, we start with x minus h squared, but now we have it over something. And we're going to say that's over a squared plus y minus k squared, once again similar to our circles, but now that's over b squared, and this is equal to 1. Now let me show you how to graph these. I've given you two simple examples down here. So the center of our ellipse on this first one on the left is going to be the point 2, 1. The value of a is the square root of 9. So a equals 3, and b equals the square root of 4, which is 2. So this is a very straightforward approach. We go to the point 2, 1, and from 2, 1, because underneath the x is a 3, we're going to go out 3 units to each direction. Now, the b unit is 2, so we're going to go up and down 2 units in each direction. And now we're going to draw our ellipse connecting these 4 points in somewhat of an ellipsoidal direction or an ellipsoidal manner. So that's an ellipse, very simple. Let's try our second one over here. Our center on our second ellipse on the right is -3, -1, the opposite of each of those values. The square root of 1 is 1, the square root of 16 is 4. So let's go to -3, -1. Side to side, underneath the x, we have a value of 1. So we're going to go out 1 in each direction. Up and down, we have a value of b equals 4. So we're going to go up 4 and down 4 in each direction. We're going to draw a very narrow ellipse here between these two. Some people might realize that we have something called a major axis and a minor axis. The major axis is the longer one. On this left one, it's the horizontal. The major axis has length 6. On our vertical model, on the right, our major axis has length 8. So just some terms, major and minor axis. Just like with circles, we have a possibility that the graph might not be given to us in standard form. And if that's the case, we're going to need to complete the square, once again, and transform this into standard form. So let me show you how that works. First of all, we're going to group the x's and the y's together. So we're going to have 25x squared plus 100x squared plus 4y squared minus 8y, and this equals negative 4. Now, for some reason, the number was on the left-hand side of the equation with the x's and y's. We would move it over to the opposite side of the equal sign. Our second step is a new step. Unlike a circle, we're going to factor out our leading coefficient of our squared term. So we're going to factor out 25, leaving me x squared plus 4x. Now we're going to factor out the 4 out of the y squared, leaving me y squared minus 2y. We're starting to look like what we have for circles, and now we're going to complete the square. So 25 parentheses x squared plus 4x plus blank. Plus 4 parentheses y squared minus 2y plus blank. And this is going to equal to negative 4 plus blank plus blank. This line is going to be our longest line of each of our ellipses as we convert them. Just like with our circles, we're going to have half of 4 is 2, 2 squared is 4, so we're going to add a 4 there. However, unlike our circles, we really didn't add 4 to this problem. We really added 25 times 4 to the problem. And so on the other side of the equation, we're going to balance the equation by adding 100. As we look at the y's, half of negative 2 is negative 1. Negative 1 squared is 1. But we really didn't add 1 to the problem. We added 4 times 1, or 4. And so we're going to add a 4 to the other side of the equation. We're 2 steps from being finished at this point. Let's rewrite the equation as a perfect square now with binomial squared. So x plus 2 squared plus 4 times y minus 1 squared equals 100. Our standard form of the equation has the equation equal to 1. So we're going to divide everything by 100. This is going to bring us to the final step of our equation. X plus 2 squared over 4, because the 25 and the 100 cancel to a 4, plus y minus 1 squared over 25 equals 1. Our center is negative 2, positive 1. The a value under our x is 2. The b value under our y is 5. So let's sketch this. Negative 2, 1. Let's go right and left 2 units, up and down 5 units. And that gives us a basic sketch of our ellipse. There we go. So let's try this one more time. We're going to start out by grouping our x's and our y's again. X squared minus 6x plus 4y squared plus 24y. This time we're going to kick that 42 over and subtract it, giving us negative 41. Now we're going to factor out, on our first problem, the 4 out of the y squared. We have nothing to factor out of the x squared. And what's interesting is, and we both have a 6x and a 6y, so that's going to make life a little bit easier for us. Now we have x squared minus 6x plus blank plus 4 times y squared plus 6y plus blank equals negative 41 plus blank for the x plus blank for the y. In the x position, we're going to add a 9. But since there's nothing out front, we're just going to add a 9 over on the right side to balance that out. On the y equation, we're going to add a 9 here. But this 9 really is 4 times 9. So to balance the equation out, we're going to add a 36 on the opposite side. Now we write it as a binomial squared, x minus 3 squared plus 4 times y plus 3 squared equals negative 41 plus 9 plus 36, which is 4. We now divide everything by the value on the opposite side of the equation, which is this 4. And let's simplify. Final result is going to be x minus 3 squared over 4 plus y plus 3 squared over 1, because the 4 and the 4 cancel, equals 1. So my center of my ellipse is 3 comma negative 3. My a value is 2. My b value is 1. So let's sketch this last one. 3, negative 3, an a value of 2 left and right, a b value of 1 up and down, and so we have a very small ellipse here. It's more wide than it is tall. So that's how you complete the square of an ellipse, and that's how we classify them and change them from standard form back and forth.